Hello everyone! Today we're introducing the product, what it actually is, how it works, and everything related to it. This introduction will be recorded in 3 languages, Ukrainian, Russian, and English, for different audiences. Some people understand Ukrainian, others may not, but they still support our country and our people. This approach removes any language barriers and gives us the opportunity to grow and improve the product even more. So the first thing I'd like to say is that STELS is a network. This is not just a product. It is a decentralized system of autonomous and automated management of digital markets. This product was developed by me from the very first line of code, meaning starting with the architecture and finishing with writing the entire product. The product is written in Rust, and it interacts with different programming languages at the execution level, its executive part. And if we don't delve deeply into the technical part yet, we should talk about the fact that STELS is a decentralized system, a modern portfolio management system for institutional players, large funds, banks, and cyber traders. I call cyber traders those individuals who seek a tool for collective portfolio management, people who are proficient in programming, strong in mathematics, and well-versed in how markets operate. STELS is a decentralized runtime engine that fundamentally relies on collective artificial intelligence. That's why STELS is called artificial market intelligence, because it's not just market intelligence, it is artificial market intelligence. It is a smart market that you build for yourself. If we look back in time, we once had simple trade carts. Then digital markets appeared, and we had terminals. You could place orders, manage positions, track your returns, and so on. Well, STELS is the next generation. The generation of modern automation and connectivity to various markets, both decentralized and centralized. In other words, you can manage crypto markets and beyond, since STELS can connect to different types of markets. We'll talk more about this later. You can link your accounts and seamlessly manage your markets. Now, let's start with the welcome page. The welcome page provides a brief description of what this product is. STELS is built around AMI models, artificial market intelligence models, which are programmable scripts that execute in real time across the network. There are no traditional servers in STELS, only nominators who maintain the network, while all execution happens directly within the network. According to the latest benchmarks, we achieve 71,000 parallel operations per computer per nominator. With minimal system requirements, we can scale up to 700,000 operations if we expand resources through GPUs or, better yet, NPUs, neural processing units, as they are more modern processors. STELS is a neural system that learns, and you train it. Now, let's talk about key features. First of all, intelligent models. Programmable trading models that you design yourself, and they autonomously manage your assets in a passive mode. You can program the market the way you want, structure it mathematically according to your needs, comply with regulatory protocols, and manage your portfolios accordingly. STELS is a global neural network focused on collective intelligence. I designed the architecture not for managing just one account, but for managing many accounts, where each account represents a part of the neural network that you train. As of today, STELS is integrated with exchange integrations, meaning centralized exchanges, and decentralized integrations will come closer to summer. For now, it's centralized exchanges, and we're working in partnership with Bybit Exchange, especially ahead of the Token 2049 event. All code within STELS is dynamic. It's generated and lives directly in the network. Every script is fully protocolized and operates in real-time runtime engines. There are no servers executing code. It's the network itself executing everything. The network is a heterogeneous multi-layer system. I will explain this structure in more detail later. Networks can be public or private, meaning you can set up your own encrypted and secure private capital management network, which can even be stored on a USB stick. Nobody will ever be able to breach it because of the multi-session security structure. I have worked professionally in cybersecurity for many years. The best security is time, delaying a hacker from performing an operation. That's why I designed a system of multi-layered sessions that can regenerate themselves in real time. Even if a hacker manages to learn about your session, at best they could only access a publicly available layer of the system. They will never be able to access your private zone. There is also a marketplace of ready-to-use pre-trained models and widget dashboards for setting up your workspace to manage your operations. Once you join the developer group, you'll be given a DevNet token, special access to the network as a nominator, where you can deploy your Docker container, You can either run it locally on your machine or quickly set it up on a server. For now, we will be connecting to a local nominator that I have deployed on my machine. I will show you the full path, the most important steps, and then we'll proceed to the next stage of the webinar. After this introduction, we'll dive into scripting, APIs, services, model training, model deployment, how models generate yields, how they operate, why collective management is better than just speed, and why collective management with speed is a major advantage. We'll also discuss how to counteract market manipulation, scalpers, bot farms, and other challenges. STELS was designed as a large-scale institutional product, specifically to tackle such issues and enable automated and transparent market making. Transparency is key. Once you set up your nominator, you will receive a PID, parent ID, a unique DNS name running within the internal DNS network. Initially, you'll access it with a temporary password. Later, when we move out of DevNet, you'll connect using a wallet, and only your private key will allow you to sign and access your nominator securely. For now, it will be password-based. Sockets and API servers can be located at different endpoints. It all depends on how much you care about your security, meaning the security of assets, data storage, and everything related to it. It's important to understand that a socket can run on your local server or somewhere remotely, like a server in Japan, in an encrypted form. In this case, the socket will be local, but you can later deploy it elsewhere if you wish. I am connecting to a local machine, both to the RPC server API for interacting with the node and to the socket for listening to data, aggregating it, and working with it. The connection settings can be made to DevNet using different protocols: Fix or WebFix, WebSocket or Quick, Nominator, Heterogen, or Sonar management. In this case, we are connecting to nominators. We'll discuss the other instances later. Here we have a developer checkbox. It enables advanced settings with an open terminal, code writing, and other useful features. So, let's get started. The first place we land is the laboratory. Upon first deployment, meaning when you first enter the nominator, you don't have any connected accounts yet. You just have a clean nominator, which is currently listening to markets, gathering something, aggregating some information, and monitoring different markets across different exchanges. STELS is connected to all possible markets thanks to its heterogeneous system. Let's talk about the interface. On the right side, there is an application lock button. This is the logout from the system. On the left side, there is a description. At the top and bottom, we have the Sonar tab, the Net tab, and a plus sign. The plus sign is for adding an account. If you don't have any accounts yet, when you first log in, you are immediately taken to a form to create an account. An account is the core element that drives all further actions in STELS, because the market is made up of accounts. Your balances and various features are stored there. But first, let's talk about the network. Right now, it's empty because we haven't added any accounts yet. We will go through that process, but let's start with the main part. The network is heterogeneous. What does that mean? It means that in this network, the connectors are independent and serverless. They don't run on a specific server. You can deploy them with minimal involvement from developers, meaning you simply deploy a connector via a Docker container. It is serverless, just a function that performs hybrid connections through different APIs available to us at this stage. There is key information about the network structure, and I'll explain it now. There's a main sector of the heterogeneous network that indicates what kind of network it is, which module is responsible for forming this network, and how many nodes are deployed. These are real nodes running in different parts of the world today. In this case, there are 7 nodes. Main configuration. In this configuration, it is specified that the type of this network is centralized exchanges with a market interaction loop cycle of 500 milliseconds, meaning 2 ticks per second. This provides minimal latency, which is quite decent for starting to work with markets without extremely high speeds. If you have a professional nominator with, for example, a connected GPU, NPU, or a large number of CPUs, the latency can reach nanoseconds or microseconds. It all depends on the situation and your specific requirements. In this case, the network is connected to 3 markets: Bitcoin, Solana, and Ethereum. The connectors are linked to OKX, Gate, Bybit, Binance, HTX, Crypto.com, KuCoin, WOO, and Ethereum. You can add even more depending on the needs of your nominator and the accounts you will be creating. As I mentioned earlier, each heterogen is serverless, but it has a nearest point of connection to the market for aggregating and transforming the data that is fed into the STELS brain. Let's take a look. For example, there's Amsterdam. It has time zone information, coordinates, and execution time. In real time, we are reading what is happening with this particular heterogen. I will show you more details about heterogens later. Singapore, for instance, is one of them. Then there's Bangalore in India, Frankfurt, London, Sydney, and Toronto. These are the connectors currently linked to the heterogeneous network. They exchange information and supply the network with key data. The heterogens collect and transform this information and deliver it to the brain of STELS. Later, I will show you how we will work with this data. As for the structure, everything is clear here. This architecture was specifically assembled to help you understand how heterogens exchange data and operate in real time. This is our actual Earth sphere with real coordinates showing the current locations of heterogens. Let's take Asia, for example. Here's our Singapore connector. It has an IP address, and when we access it, we can view detailed information about everything related to this connector. It is currently deployed on DigitalOcean's serverless network. It has an ASN, connected markets, exchanges, its type, network, IP version, and the brain it is connected to. This is the DevNet, meaning it's currently local. It shows Singapore and its coordinates. There's also information about its network setup, its IP addresses, version, DNS configuration. It exchanges information with something called HetNet, an internet structure that provides a DNS name for your nominator's connection. Location details are also available, where it is connected, which country, demographic situation, area. Later, you will need this information for aggregation purposes. The brain of STELS analyzes population increases and decreases. It knows what's happening with demographics around the world. It gathers information globally to understand where situations are improving or worsening, providing broader market context. As for the basic configuration, if there is an exchange located somewhere in Europe, heterogens can surround it and provide minimal latency to ensure high network speed. As you can see, this is another example. Here's Amsterdam, where the population is about 17 million. What else do we have here? We also have Frankfurt, Germany, with a population of 82 million. Everything depends on the country where you deploy this node. This way, they build their own network surrounding the markets in order to work with them later. It's clear here, a network, a heterogeneous system, everything with low latency, proper data aggregation and data collection for each market in each country. For example, Canada. What's going on in Canada? 37 million. Not bad. The territory is very large. But the most important thing in STELS, specifically in the lab where you will work later, is the account. We test all systems with our partner Bybit. We are market makers for them. My current task is to show you how this works with one market and different accounts. Later, during the webinar, we'll discuss which markets to connect and why. Because the tool is quite technological and competitive, it's important to provide the correct information. Everything starts with creating an account. The first thing you will see is a prompt telling you to create your first account. We choose Bybit, follow the structure, and the system will ask you to first create an NID, a neural identifier, for this account. The NID allows the brain to understand what you are programming, whether you are creating a new AMI model or a kind of perceptron or neuron that will work within the collective intelligence. Let's give it a name, for example, STELS account. Then you add an API key and a secret key. I won't show them because this is a real account with real money on a real exchange. This is not a demo version. STELS only works with real data in real time. After you enter the details, an additional note section opens where you can record notes related to this account. For example, I can write STELS account webinar test. Click Next. It will package this structure into an encrypted snapshot and send it to the network. It will be stored there in an encrypted form. All future actions related to this account will happen within this snapshot. All right, let's proceed. Click Submit. Excellent. The account has been added and immediately a Sonar appeared. You notice that before we created the account, this initial section, let me even refresh the page to show you clearly. Now, in real time, the system analyzes the account's portfolio, liquidity, balances available for margin trading, protection reserve, asset distribution in dollar equivalent, and margin summary. It also provides information about whether there are multiple accounts linked. Later, I will add a few more accounts to show you how it works. The main information here concerns margin capacity, including its rate, active accounts, risk analytics, and breakdown. We can see the amount of assets we are currently working with or that are available on this exchange. Now notice that there is a module called Sonar, an aggregator of the entire pool across all accounts. Here, we can view consolidated information across all accounts in the system. Additionally, at the top, a new tab has appeared, the STELS tab for our NIT, Neural Identifier. When you click on it, you enter the account management model for a single account. In Sonar, you view the whole pool, but here you work with just one account. This is a document-oriented interface, a professional-grade UI designed for working with funds and corporate clients. It's structured specifically to provide a simple, lightweight, and clear data visualization for executives, helping them quickly understand market dynamics and make informed decisions. Markets are becoming extremely fast, so making strategic and tactical decisions in real time, whether it's opening, managing, or exiting positions, is critical. If you open it on a tablet, the interface will remain document-oriented, providing access to all the information about active workers. In this case, under the AMI tab, we have an overview, where you can see an evaluation of all your assets. Currently, we only have USD balance available. You'll also see notes, account type, exchange name, account ID, the neural identifier. There's a tab for assets, listing all the primary assets you're working with. A collateral tab, showing margin collateral if you're using margin trading. And the AMI tab, which stands for Artificial Market Intelligence. AMI is a programming environment for your neuron. You can customize it however you want, like your personal library. In real time, ARMI listens to the STELS SDK, receives live code from it, and processes it accordingly. If you click Info inside AMI, you'll see a snippet of code, a small console log, a default AMI script running, just for initial visualization. This becomes especially important when you've developed a strategy and need to document, protect, and review it, either with your manager or strategic decision makers. There's a whole library of scripts you can rely on here. There's also a prices section, a quick access view providing a compact snapshot of the current market state. Everything is designed to be compact and non-intrusive. When you're inside the Account tab, a new option appears, the ability to switch to a scripting terminal. In Sonar, you won't see it. In an individual account view, you will. Click it, and you'll enter the professional AMI, scripting, and neural programming terminal. There's a lot of functionality here. We'll go through it together, including how to program markets, how the SDK works, how to write scripts, how workers display and interact with information. For example, let's say I want to output account data to the console. I'll retrieve some valid information about the wallet state. Let's take a look. The system will deploy the worker to the network and launch it. The worker is already analyzing necessary data in the background, but by deploying it manually, we can output and directly work with that information in the console. Inside the console, we can see information such as total equity, all balances, and various data points tied to this account, including its positions. Basically, everything you want to inspect, since we're analyzing both the spot and futures markets via connectors. These are the so-called heterogens, and this connector here is one of them. A heterogen is essentially a connector module. We understand that data processing can happen directly within the script. That's the first point. The second point, and we'll go through it quickly, is that every worker, i.e. each account, has a main script. That's the primary logic we configure. For instance, to work with the central intelligence. And then there's the AMI script. By the way, you can clear the console at any time while working or writing your strategy. Right now, the main script is active. What does it do? It fetches the spot balance of this account, checks if the account has any futures positions, generates a timestamp, builds a composite structure of the account. Then it opens a secure encrypted channel through which data is transmitted. It's noted here in the UI that this is a private service channel, and this is the account widget. I'll explain widgets in more detail later. So what's happening? We've written some code and securely transferred it locally to the account. It's now inside the system, running and analyzing data in real time. Through this secure channel, we can request data from the AMI script. We can ask it, give us the current information from the main script for this account. In this case, I'm referencing Bybit and requesting the account connected to our NID, neural identifier. Let's verify it. At this point, AMI is retrieving account info from the main script. The main script analyzes it, sends it into the private channel, and the AMI script reads it from there. You can have as many AMI scripts as you like. You can even share your balance data with other workers in the system, meaning that one worker can inform another that, for example, the STELS account holds a specific number of tokens. To fully grasp this system, it's important to understand how the data pipeline works. The data gathered by the main script is displayed right here. Look here. We have a connection, it's active, and everything is fine with the account. If we disable the worker, the connection will still technically exist because the exchange confirms that the API keys are valid and everything is okay. However, the data for this account becomes inactive. It's no longer updating because the worker isn't running. It stops sending data through the secure channel about what's currently happening with the account. It doesn't check balances, and nothing changes. See that? But as soon as I start the worker, you'll notice that updates begin. The balance starts to refresh. See? It begins updating them. The main task here is that it collects wallet data. All your margin balances, everything related to your rates. This section shows balances when you borrow assets from the exchange, and here are your open futures positions. Over here, we see the coins currently available in your balances, along with the account's configuration. It's important to understand that this private channel through which the STELS system is communicating with the worker is tied to the account. We can't delete the account from the system because regulatory rules prohibit that. Regulators don't allow any entity to simply delete account records. So instead, we take a snapshot of the account and only update the API keys. Why is this necessary? Because a worker might run continuously for, say, 3 months and then the keys expire or become invalid, but the worker must continue operating. That's why we either automatically refresh the keys or request the client, the investor in case we're managing their accounts and automating their portfolio, to manually update the keys so that the account remains unchanged. This way, the snapshots and full account history are preserved. The main control buttons here are Stop Worker and Run Worker. What's also important is that each worker operates inside the system, and most crucially, workers can exchange information with one another. That's a key concept, because they need to be able to collaboratively manage trading strategies. To demonstrate this, what am I doing now? I'm adding another account. Let's name it something like Burger. Now let's also assign it Bybit keys. This is another real account. We're currently preparing these accounts for launch and configuring strategies for the Token 2049 event so that you can see in real time how collective management works within the STELS team. I'm the lead architect of the product on both the back end and front end. And for me, it's very important that there's a shared understanding of the overall context in what we've built. We've created a major regulatory grade product that allows automation not just for markets, but also for smart cities, autonomous vehicles, and basically any system that requires high-speed coordination. This system is currently tested on high-frequency markets, where speed is critical. The speed of data exchange, data retrieval, analysis, and everything else. So let's go ahead and launch this. Burger account test, join STELS. We'll package the snapshot and send it into action. Perfect. Now it's going to say that you can keep adding accounts, even 1,000 of them, in a loop if you want, depending on how you want to structure your programming. Now we see that 2 accounts have appeared in the tab. See, we have our original STELS account, which we've already worked with, and now there's Burger. Let's go back to the Burger account. Burger has $399,000 in its balance. That's real USD, fully prepared for launching trading operations on STELS. It also has a ready AMI, just like the STELS account does. And you can have as many AMIs as you like. 2, 3, 4, 10. It doesn't matter. I'll generate a few more now so that it becomes a bit clearer for you. When we open Burger, we can see that it also has a main script, which handles data analysis. And it has a note that says, "Hi Burger, I'm here to help you with your runtime cyber trading." This note refers to the generated script, which is designed to help configure your market operations so you can manage them like a cyber trader. Here, it provides detailed information about accounts, positions, configurations, and the available assets it holds. Okay, moving on. Burger can also exchange information via internal channels. These are local scripts, while main is a global one, meaning the main script can be used for communication between nominators. Let's say you're building a large strategy for collective management, managing a $1 billion Bitcoin fund, for example. Or maybe you have one nominator based in Asia, another in Africa, and you want to run an arbitrage strategy on Bitcoin. In this case, the nominators need to exchange information. So, main has access to the external network AMI scripts are local, and you configure them to exchange data between accounts within your nominator. Now let's create a basic function. Function myTime, return date now. And we'll store this in a variable. Let's say variable A. Here's what's important. Using the STELS SDK, we can transmit data through a secure channel to the STELS worker. We're calling the STELS SDK, which has a local database. We use the method set with an array of keys to form this channel. The first parameter, local net, is required because it defines the security scope. The second parameter, for example, can be time. In this case, we take the data from variable A and store it inside this secure channel. We're sending information about my time into the local net time channel, and it will keep transmitting it in an infinite parallel loop. That means STELS is not a temporary engine. It's a runtime engine, and it always runs. All operations are synchronous and parallel. Recent benchmark tests showed 71,000 parallel operations per nominator using just 4 gigabytes of RAM and a minimal processor. If you're running on a powerful computer or server, it can reach up to 500,000 parallel operations per second. That's important. Now, in the Burger account, let's also place an object like NID. Burger. This is just so we can identify it. We launch this service, start the worker, and it becomes active. Now it starts transmitting information into the secure channel. So now the AMI script, this lightweight app of our Burger account, is sending data into the secure channel. Now, STELS from within its AMI can listen to this channel. Let's take a simple example. We'll perform a GET request using the STELS SDK, querying the local net and time channel. We run the worker, and we'll see that the AMI worker is now listening in runtime to all the information being sent from the Burger account. What does this demonstrate? It shows that STELS can transmit critical data between accounts, data that's needed. For example, we can transmit information about the available funds from one account to another and program arbitrage logic between them, such as how many assets were bought, how many were sold, and where those assets were directed, whether to a DEX or a CEX. The STELS SDK offers a wide range of interfaces, allowing you to program and control the market. This system is essentially a market programmer, where you configure the protocol, and through that protocol you configure your investor's market, your own or any other, using a multiple account system. Everything is decentralized. No one can damage your nominator. No one can stop your markets, except the exchange itself, for example, if it bans your account for any reason. But STELS has built-in wash trading detection. It automatically blocks wash trades. STELS works with various protocol. It understands what exchange it's dealing with, what the rules are for each. You can program all of this. Once you create a channel, the information from that channel can also be passed into widgets. I'll show you that later. Right now, our main task is to understand a simplified form of market programming in the terminal, so you can see how we interact with the AMI models we write. Here we can call APIs for various methods. For example, we can call the API for order creation or other actions. In the following lessons, I'll show and explain much more about how this works. But for now, this will be enough. It's important that you understand the architecture and how STELS works. What is it? What is Sonar and what is pull liquidity? You can see that now two accounts are already aggregated here. Distribution is happening from both accounts. For example, my burger has $399,000 and STELS has $2,000. And here's the aggregation. All this data is collected, analyzed, and passed into execution. There's also risk analytics with a breakdown across all accounts. We now have the burger account and the STELS account displayed. That's all for today. We're preparing for the webinar, getting ready for programming and for math, because a modern automation system for cyber markets, especially in digitalized markets with proper management and regulation, must be fully automated. Markets are no longer markets of speculation or waiting. You can configure them once or ask a professional to set it up for you. Eventually, you'll become those same professionals, like the developers of STELS, and clients will come to you asking to program their markets according to specific protocols and strategies, so they can sleep peacefully and not worry about what's going on in the market. STELS can manage up to 5,000 accounts within a single nominator. That depends on your computing power. It doesn't matter how much money is in those accounts. The most important thing is low latency. And that is exactly what a heterogeneous network provides. It ensures a seamless data structure for you to work with. Let me quickly show you the canvas. Here, a separate pool is connected, just as an example. When you write your own communication channels, each channel can be linked to specific data, and this data appears in the canvas as widgets. Let's look at a book, say Solana/USDT, and let's also check Binance. This is for your monitoring and decision making in real time, with delays up to 500 milliseconds, sometimes a bit more depending on network conditions. But we can accelerate the network in mainnet. We can even bring it down to nanoseconds. We just don't need that right now. Here you immediately see two order books, and the spread is clearly visible in relation to the analysis. Order monitoring is active. Every order is under monitoring by STELS. It knows about every order. There's also system monitoring. You can add any widgets you like, and all of these widgets are generated from your channels, which you structure and save. I think in the next lessons we'll start working with AMI, scripts and protocols, and with learning the methods for order execution, how to call positions, how to program these positions, how to monitor account balances, portfolio diversification, and many other nuances. But that's for future videos. This one was more of an introduction to help you understand what STELS is and how it works. It's a document-oriented professional terminal for interacting with your nominator. That's it. Thanks everyone. See you in the next video.